A very good morning to all of you. Today we are continuing the topic matter in our surroundings. But children, as we are meeting after 2 weeks, let's do a short recall. We did about matter. That matter is something which occupies space and has mass. We also did characteristics of matter, and that is, it is composed of particles, and these particles are continuously moving. Particles of matter have space between them, and particles of matter attract each other. So these were the characteristics that we learned. We also did about diffusion, and today we are going to do about effect of change of temperature on states of a substance. So let's first of all talk about melting or fusion. On heating, the solids change into liquids. Now, what is the reason behind it? Why does a solid melt? On increasing the temperature of solids, the kinetic energy of particle increases. Now, this we learned in the previous lecture also, that on heating, the kinetic energy of particles always increases, means they start to move more rapidly. So, they start vibrating with great speed. Here the word is vibrating, and we learned last time that solid particles do not change their place, they just vibrate on their own position. So when we heat solids, the vibrations become even more. The energy supplied by heat overcomes the forces of attraction. Now, why does the speed of particle increases? Because of the heat, the force of attraction between the particle becomes weak. So heat is used up for overcoming the force of attraction. So the particles leave their fixed position and start moving more freely, and a stage is reached when solid changes to a liquid. So this is how melting takes place, and there is an activity very popularly associated with it. Let's start the activity. Melting of ice in a beaker and observing the temperature changes. You can see the diagram here. Look at that. There's a tripod, a burner, wire gauze, and on this setup is a beaker. This beaker is containing ice cubes, and there is a thermometer hung in it, and there's a glass rod in hand of the person who's performing the experiment. This is to stir the whole substance. Now, what are they trying to notice? That what happens to ice on heating? Now, the observation of the person during the experiment is that temperature of ice is 0, which the person notes through the thermometer, which is noted with the help of thermometer. Now, to our surprise, we find that it remains 0 till the whole ice melts. Now, what happens when that person starts heating? The temperature of ice and the water so formed remains same throughout, although heat is getting consumed. Now here comes something very special, latent heat of fusion. Latent का मतलब होता है hidden, जो छुपी रहे. And let's study the reason. The temperature of ice does not rise even though we continue to heat the beaker, because this heat gets used up in changing the state by overcoming the force of attraction between the particles. We recently learned in the previous slide that when heat is supplied to a substance, the particles acquire more kinetic energy, and that heat tries to overcome the force of attraction between the particles. So same is happening here. As there is no rise in temperature, it is considered that heat gets hidden into the content of the beaker and is called latent heat of फ्यूजन. नाउ बिकॉज चाहे इस सारी आइस को मेल्ट करते हुए 10 मिनट लग जाएं, 15 मिनट लग जाएं, हीट तो लगातार कंज्यूम हो रही है, लेकिन फिर भी आइस क्यूब्स और उससे बना हुआ पानी उन सब का टेम्परेचर ज़ीरो ही बना रहता है काफ़ी समय तक, जब तक सारी की सारी आइस मेल्ट ना कर जाए। तो उस समय जो हीट वो सब्सटेंस एब्जॉर्ब कर रहा है वो दिखाई नहीं दे रही है। So that heat is called as latent heat of fusion. And please remember, latent heat of fusion for water is 3.36 into 10 raised to power 5 joules per kilogram. Now joule is the unit for heat. Thank you.